Alright guys, we are going to start section 1-3. Section 1-3 is over real numbers in the number line. We're going to take 2 days to cover this section. So today the only thing that we're going to be talking about is squares and square roots. Hopefully this is a review, so it'll be another easy section for us. Let's start with a couple formal definitions. First one is square root. This is going to be a number that is multiplied by itself to form a product. This is going to be one of our SMART goal words, so you will be tested over this several times throughout the year. The next word, square. This is a number raised to the second power. For square, you're not going to be tested over it, but I think it's really important to know the difference between square and square root. So I wanted to make sure I included that. For square, I wrote there 3 to the second power. I'm not going to read that as 3 to the second power. I will read that as 3 squared. So I just want to make sure that you know what I'm saying when I say that. So let's look at what I have written there. I have the square root of a, and we're going to give some formal definitions to this. So this whole thing is actually called a radical, and you may not have heard that before. If not, that is okay. So we're going to call that a radical. The a that is inside our square root symbol, that is the radicand. And then that square root symbol is also called the radical symbol. So those are just some couple things that are nice to know. Let's look at a couple examples. We're going to be simplifying square root expressions. And our directions are going to look something like write the simplified form. And these are going to be perfect squares, so they should be easy for us. The first example is the square root of 49. Well, to figure out the square root of something, we need to think what, there we go, that's question mark, times itself equals 49. Well, hopefully we know that 7 times 7 equals 49. So then that would mean the square root of 49 would equal 7. Okay. Another example, the square root of 1 over 36. 1 over 36, it's a fraction, but we can also think of this as the square root of 1 over the square root of 36. Okay, let's break that apart. Well, the square root of 1 times 1 is 1, so then square root of 1 is 1. Square root of 36, what number multiplied by itself equals 36? Well, that is 6. So the square root of 1 over 36 is going to be 1 over 6. Okay. And our next type of example that we have is going to be estimating a square root. Not all of our numbers are perfect squares, so we're not going to use a calculator, but I do want you to be able to tell me what whole number is it closest to. Okay, so find the closest perfect square. Our first example is the square root of 63. So we first need to decide what two perfect squares is it between. Well, if you know your perfect squares, we know that the square root of 49 is a perfect square, and the square root of 64. And the square root of 63 falls nicely in between those. The square root of 49 is 7. The square root of 64 is 8. However, I want you to be able to tell me, is the square root of 63 closer to 7 or closer to 8? Well, I can see 63 is closer to 64. So square root of 63 is going to be closest, there we go, to 8. Okay. The next and last example I have is square root of 107. Again, we want to think what two perfect squares is it between? Well, the square root of 100 is 10, and then if I go up, the square root of 121 is 11. So the square root of 107 falls somewhere in between 10 and 11. It's going to be a decimal, but what perfect square is it closest to? Well, 107 is closest to 100, so it's closest to 10.